So my name is Mario. I'm a software developer working for VoltDB. I've been working there since the beginning. It's about 4.5 years. VoltDB is a scale-out, shared-nothing SQL database designed to run on commodity hardware. We're targeting high-velocity OLTP applications. And by high velocity, I mean hundreds of thousands to millions of transactions per second. And transactions, so durable, serializable isolation, and very expressive. It's a SQL database, so we're trying to retain all the goodness of SQL, but with the ability to scale out and have much greater performance per node. So if you're working on an OLTP application, you have to deal with scaling challenges. Either you're having trouble scaling read throughput, you're having trouble scaling write throughput. Read throughput, maybe not so hard. So you have I/O bottlenecks. So you can add caching to your application through tiers like memcached. So now you're storing your data in memory twice or more. You split your read or write workloads and offload reads to replicas. In that case, you're dealing with inconsistencies, caching validation. Can I safely do this query on a slave to get the right result? It pushes more complexity on you and your developers, increases risk. This is the total cost of operating. And then there's money. You can scale up. You buy bigger hardware, more exotic hardware. You get rapidly diminishing returns. So you can go with non-commodity hardware, or you can just buy really expensive commodity hardware. You can also buy more expensive database products. You can pay license fees per core. There's also the additional IT ops expenses of operating these expensive, complex single points of failure. You can also sacrifice your data model to get additional performance and deal with your read or write and scaling problems. So you can switch to a document store or a key value store, you have primary key queries, and you can give up analytics and the relational data model. You can also give up transactions, so you get reduced isolation levels. VoltDB provides serializable isolation, so transactions are particularly isolated from each other. We give group commit, so you can match multiple SQL statements and arbitrary application logic together. It executes on the server with complete isolation. And you may sacrifice durability and consistency across nodes or replicas, any of those. Or you can do application control sharp, additional complexity being pushed onto your developers. So in addition to losing transactions, losing an expressive data model and query language, you also have to deal with an application that's aware of how data is distributed across the cluster. And you have to write your own software to add nodes, remove nodes, take distributed snapshots. It's a lot of extra costs. So VoltDB, the goal of VoltDB is to keep SQL, keep transactions, keep all the good things as much as you can, and still be radically faster per node, supporting hundreds of thousands of transactions per node, and not simple transactions. Try and push back all that complexity in terms of data model, lack of isolation, and managing their own sharding. So we deal with I/O bottlenecks by requiring your data set to fit in memory. Your data is still persistent. It turns out that persistence is still relatively easy to do, even on commodity hardware and non-expensive hardware. We can make all the I/O sequential. That's all just writes to disk. Because all your data is in memory, we can serialize the execution of transactions. Without blocking on disk reads, there are no longer any need for long-running transactions, so you can run them back to back. Also, because you're sharding, you don't need to have shared data structures. You can just shard down to the core level and have a dedicated core service each transaction. And that avoids the overhead of blocking and latching. You save on money, so you can linearly scale on commodity hardware. You can find the sweet spot in terms of hardware cost, pick that, and add more nodes to meet capacity. Also, very low cost per transaction. Again, this is for high velocity applications, so we're really focused on hundreds of thousands to millions of small transactions per second, or small transactions. We have open source version, so you can try it out. Some people are running it in production. We also have commercial licenses available to support additional functionality. So we're keeping the relational data model, we're keeping SQL, so we have declarative query language. We also support JSON and JSON expressions, so you can have string columns that you can pull JSON fields out of. You can index on them as well, so it's competitive with NoSQL solutions in terms of data model flexibility. And we keep transactions, so you get full durability, you get full isolation, And you don't have, and the system can even transparently load balance reads across replicas if you need additional read throughput. None of that complexity is pushed to you. And we also do sharding for you. So we support distributed ACID snapshots. We support rejoining nodes on the fly if they fail, adding nodes on the fly. And we also handle distributed transactions. So if you want to do a scan of your entire data set and have the aggregate pushed down for you, you don't have to write that code, we'll do it for you. So what are the characteristics we want from a high-velocity database? So I mentioned before, lots of independent updates. So very heavy write throughput. Again, a lot of databases will try to scale out reads, but they don't really handle write throughput quite as well. For Volt, reads and writes are mostly the same because there's no locking or latching. So you don't need to take a write lock, and there's no lock conflicts. We need high availability, so we have to stay up in the face of failure. That means replication, and VoltDB offers built-in synchronous replication, so you don't have to deal with inconsistencies on failures, and you don't have to deal with slave lag or any of the other issues that would typically come up. Support complex manipulations of state per event. I want to decide what ad am I going to show the user next. I need to write down the ads that I've seen, etc. And then also integrate easily with high-volume analytic data stores. So it's not one size fits all. We solve the OLTP problem, but we're also helping you solve your analytic problem by allowing you to ingest data into Volt, process it, and export it out to other data stores. So these are some example use cases. What they all have in common is lots of really small transactions and terabytes of data, so it fits in memory. So what does a VoltDB application look like? So this is Voter. It's a benchmark. It's doing 180,000 transactions, a little bit less. This is on my desktop, so not a lot of hardware. It's just a single socket i7. This is our C# client. It's not a particularly fancy client server either. It's on Gigi networking. So what? Everyone's seen benchmarks. So typically they're using expensive machines, expensive interconnects like InfiniBand, very large clusters, read-only or read-mostly workloads, single key transactions only, so they're not really accessing multiple tables. There's no application logic as part of each operation. It's not really representative of real application transactions. And this is assuming these systems even support transactions. So Voter is 100% write, 4 SQL statements in each transaction, 2 batches of SQL, a read to validate business logic, and then a write. It's a 1-table insert that updates 2 materialized views. There's 4 index lookups, 2 index updates. The database is maintaining a distributed replicated state that contains configuration for some of the business logic that you can update transactionally. It's all with serializable isolation and ACID. And that's it. VoltDB in a blink. Yes?
So let's say I'm scaling out from like a MySQL database and it's slowing down. Like, is this a drop-in replacement, or is this something I'm going to have to do a lot of extra work to put into place?
It's not a drop-in replacement. So you can do ad hoc SQL. So for your less frequent transactions, you can continue to use ad hoc SQL. We have a JDBC client you can use to do that. For things that are really high volume, you're going to want to write stored procedures and push that logic into the database to avoid round trips to the client and pushing stuff over the wire. So in that sense, it's not a drop-in replacement.
Who is your competition?
I would like to think that we have no competition. So there's MemSQL, which is comparable in terms of performance, but they only support single-statement transactions. So not many people have transactions, not many people have the same write throughput. So like MongoDB is extremely fast at reads, but it doesn't have quite the same write throughput, especially when you want to update multiple tables, multiple views, etc. Yeah?
A couple of things. You said it's all in memory, right? The first thing.
Yes,
okay,
in memory and persistent.
Second thing you said it's no locking or latching.
Yes.
How is concurrency maintained in distributed?
So, because it's a sharded database, if a transaction only touches the data in one shard, then we can bring the transaction to the shard, run it beginning to end, and then send the result back. And so, because the shard owns the data, it's a single core on the machine, there's no need for locking or latching. It owns all the data.
So, like if it's a distributed database, then a shard could come from any direction to the same, quantum of data. It's not a single transaction, or you said it's in a single transaction you can do multiple things too.
Yeah, via stored procedures. So if you want to do multiple SQL statements and arbitrary logic, you can write one of our stored procedures to do that. That runs on the server, and you can do as much as you want on one shard. And we support cross-shard transactions. That's accomplished through messaging instead of locking or latching.
Okay. So it still does one form and either wait mechanism somewhere.
For cross-shard transactions,
Yeah.
yeah, for cross-shard transactions, there is communication through messaging, so it's an active model. Yeah.
Could you foresee a PDO driver for this, or did you have?
We have a PHP driver. It's not PDO. We don't have a PDO driver yet, but we're interested in hearing how people want to use PHP. It's a very popular client library. Any more questions?
Yeah. Paying customers?
Customers. Paying customers. Yes, we have paying customers. So we're 4.5 years old. I don't know off the top of my head. I know the number that they use for marketing is 130. It's, of course, not the number of paying customers. I really don't know.
Thank you very much.
Okay.
Join Boston New Technology Meetup. Sponsor an event or a venue. Present your idea and attend to network with Boston's brightest. Details are at www.bostonnewtech.org and in the video description.